To theory of computation class. I just overview the definition of deterministic PDA. Let a PDA P contains 7-tuple representation, and if that PDA is called as deterministic means it should be satisfy the following two conditions. The first condition is that transition function contains 3 parameters in it, that is a particular state, and the second parameter is the symbol on input tape, and the third one is the topmost value on stack. Depending upon these conditions, it has only one member for a particular state, then it has only one output state. That is the first condition for satisfying deterministic PDA, and for that particular transition function it should not be empty. So if these two conditions are satisfied, then that particular PDA is called as deterministic. Suppose if you want to define a non-deterministic PDA for a single transition function, it has more than one function. That means it has more than one state, one output state. That is called as non-deterministic PDA. So comparison of DPDA and PDA, which one is more powerful? DPDA is only more powerful because sometime NPDA may produce an ambiguous grammar. So how can you say ambiguous grammar means? We already know the definition of ambiguous grammar. If a grammar contains a particular set of productions, and by using that productions, if you derive more than one derivation for a same input string, then that particular grammar is ambiguous. So NPDA may also produce an ambiguous grammar because there may be the possibility of more than one output state for an NPDA. But DPDA only produce only one output state. So always DPDA produce an unambiguous grammar. So comparison of these one is DPDA is more powerful. And comparison of finite automata with PDA, which one is superior? Obviously PDA is superior than NFA because we are using stack in PDA, and stack contains the set of alphabet symbols in it. So by using that stack only, PDA can easily determine the input notations. So that only we can able to say that PDA is superior than NFA. And the next important concept is conversion of context-free grammar to push-down automata. So in previous problem, the input is given in a language format. From this one, we can able to construct a PDA with implementing 4 steps in it. That is, we just draw the transition diagram for the given context-free language. Then we write the procedure for that particular input symbol, any input symbol with push operation, stop or pop operation notations. Then we try to write the transition function based upon the transition diagram. Then the fourth step is validation of our transition function. By using this only, we can able to implement a PDA. Instead of CFL, if they give the CFG means how to construct a PDA. So let G is a context-free grammar which contains 4 parameters in it, that will be considered as CFG. If we want to construct a PDA, that should also accept that particular grammar. So that is L of G by empty stack with the following conditions. So how can we write it? So by using 2 different cases, we can able to produce a PDA notation. Consider a CFG to PDA form. It based upon 2 cases. The first case is if any grammar contains terminal symbol. So we already know that grammar contains V, T, P, S. V is a non-terminal, T is a terminal symbol in a particular grammar. So based upon this variable and terminal notations only, we can able to write a push-down automata notations. Push-down automata means the input for push-down automata transition function is 3 and the output is 2. So we only write these notations for a given grammar. So for every terminal symbol A, which means that A is a symbol which is available in a grammar. We can able to write it as tilde of these three values. So what are the three input parameters? State, alphabet symbol on tape, and the symbol on stack. So these two are same. So we just write the same symbol at second and third parameter. And the output means we always write epsilon as the second parameter with the current same state. So this is the terminal notations PDA function. And if any non-terminal is available, that means that non-terminal must also always contain a production in it. For example, A implies beta is a production in a given grammar. So if any production is available or if any non-terminal is available, we can write it as tilde of Q, and the second parameter should always contains epsilon in it, and the third parameter of input is a non-terminal, which is equal to the right side of that production value that should occur at second parameter of output notation. It should be written as Q comma beta. For example, if any production is like E implies E plus E by ID, then we can write it as we can able to write terminal symbols from the given production. The terminal symbols are plus and ID. So by applying case 1, we can able to write it as tilde of Q. First terminal symbol is plus and the second terminal symbol is ID, which is equal to Q comma epsilon. So there is a two transition functions for two terminal symbols. So consider this production. This production contains only one non-terminal symbol in it and two productions are available. So if you separately write those productions, E implies E plus E is a first production, E implies ID is the second production. So it should contain two output notations. So tilde of Q epsilon, that non-terminal symbol E equal to, this E contains two notations, so that should be written as a second parameter. So Q comma first production right side value is E plus E, second parameter second production right side value is ID. So in this way only we should write the context free grammar to push-down automata notation. So let us take a problem. Construct a push-down automata for the given grammar. So first step is we should write a given value. So given values are, we should write the variables and terminals. Based upon this notation only we can able to construct a push-down automata. So from the given notation, so I write it separately. So E implies E plus E is the first production. E implies E star E is the second one. E implies ID is the third one. So the left side of all these three productions value is E. So only one non-terminal symbol is available for this grammar. The terminal symbols are first production right side contains plus, second production right side value star, third production right side value is ID. So based upon case 1 is for taking terminal symbol. So tilde of Q plus plus, that is the first notation. Tilde of Q star star is the second transition function. Tilde of Q ID is the third value. So these all values have Q epsilon. So this is PDA. And case 2, that should be written for non-terminal. So Q epsilon, the given non-terminal is E. So totally 3 values are available. The first production right side value is E plus E. Second production right side value is E star E. Third production right side value is ID. So these 3 values are available. So in this way we can able to write the push-down automata for other notations. Thank you.